the process. And by means of the process, to control the global market.
Good day. This video serves as the introduction to a series of videos illustrating how one can create a predictive model which is simultaneously explicable and precise. So that the videos may be maximally instructive, it is useful to understand the animating spirit behind the code. This is captured in 4 ideas. 1. There appear to me at times to be a paucity of philosophy in mathematical instruction. Simply put, if one's theorems do not ultimately admit the possibility for more and increasingly precise computation, the theorems are practically useless. And when you apply this idea in the realm of statistics, it should be observed that the point of models is not to reduce the sum of squared errors or whatever the error function is in your particular case. Rather, the point of models is to help clients make better decisions. That is to say, the point of predictive models is to help inform action. Thus, it may be the case that there is a diminishing return for an increase in precision if those temporal and computational resources, which have alternative uses, may be spent better somewhere else. Moreover, this partitions variables into the categories of fixed and volitional. A fixed variable which goes into a model is something that the user or the client cannot control. For instance, where their business is domiciled. Whereas a volitional variable is something that the user or client can control. For instance, the number of salespeople on a sales floor at any given time. 2. One should distinguish mathematics from arithmetic. Mathematics tells you what arithmetic is meaningful and what arithmetic is superfluous. I think it at times goes unnoticed that in data science, one should observe that if I hand you a set of data, you could actually perform an infinite number of computations with it. But infinity is quite too large. And so thus you have to get that down to a list of, say, 3 or 4. And that's what mathematics does. It separates the salient from the superfluous arithmetic. 3. At times, model building presents as antagonistic between subject matter experts and statisticians or data scientists. And this is because the subject matter experts will at times dismiss the data scientists since they do not understand the real world. They don't understand how things really work. And meanwhile, the data scientists will dismiss the subject matter experts since they do not understand the data. And the fact is, they are both right. Oftentimes, subject matter experts are not nearly as acquainted with the data as data scientists. And at the same time, the data scientists are not subject matter experts. They're experts in mathematics, statistics, and programming, not in medicine or in retail. And thus, this is why there exists the possibility for a necessarily collaborative endeavor. 4. The code is made to run with minimal human intervention. However, there are some times when that intervention is needed, and we will discuss those as they arise. The series will illustrate how to create a first explicable model and show that its precision rivals that of XGBoost or Random Forest. Of course, each step along the way may be finely tuned, but that will not be discussed here because that is not the point. The point is to be illustrative. The a priori selected form of the model will be that of the Mars variety, that is to say, multivariate adaptive regression splines. Now, why was that selected ahead of time? And the answer is, at least in the univariate case, such models are basically connect the dots models. And it's been my experience that clients readily apprehend those kinds of models. However, when doing any data scientific work, it must be observed that model opacity is a function of the client or the stakeholder and not the data scientist. Unlike error, which is objective, model opacity is subjective. Once a first model is created, it may then be subjected to ad hoc analysis in conjunction with subject matter expertise. Upon viewing the initial model, subject matter experts will often have additional comments, additional things they want to consider, additional data they want added to the analysis. But they often won't think of that until you present them with an initial model. I hope you have found this useful. If you have any questions, please place them in the comments. I am Ian Dieters, and I thank you for watching Full Metal Analysis.
Throw the switch! It's time to begin the procedure!
How much money will we make?
In that 3 to 5 year period, a conservative projection is we're going to generate for the company a windfall somewhere on the order of